your equilateral triangle. What do you know about your equilateral triangle you have drawn? What is it?
It has three 60-degree angles.
It has three angles that are all 60 degrees. Okay, all the angles are the same. What else do you know about it? The side lengths are the same. Okay, is there another way to classify this triangle?
Regular.
Could we say it is isosceles? It is regular also, but is it also isosceles?
Yes.
Yes. Two angles are congruent, two sides are congruent, at least two. The definition. And then we learned something about isosceles triangles maybe last week. What do you know about isosceles triangles? Maybe an postulate or a theorem.
Yes, ma'am. That's okay. Okay, I will.
So there's a postulate or a theorem that's talking about isosceles triangles. Okay? Do you know the theorem system? 50-something. Let's find theorems. Because it's one thing if I tell you.
Ooh. Two angles of a triangle are congruent, then the sides opposite those angles are also congruent.
Yes. Definition of isosceles triangle. Yes. What else? What else do we know about isosceles triangles?
The triangle is equiangular, then it is equilateral.
Yeah. Equilateral, equiangular. We've got that. What can I do to this triangle?
Perpendicular bisector.
What about it?
If a line is the perpendicular bisector of the base of a triangle, then it bisects the vertex angle.
Okay, so where's the vertex angle?
The angle opposite the side, whichever side you're doing.
Whatever side is the base, right?
Yeah.
So if the bottom is my base, if we're just going to say that, can I say that this is a vertex angle?
See?
Yes? So if I bisect that angle, what happens to the bottom? What happens to the base?
Split in two.
It's split in half. We've bisected it. More specifically, how did we bisect it?
In the middle.
It's perpendicular. So what did we just do? We made it be a right angle. Okay? If I bisected the vertex angle, what is each one of these angles at the top? Say it louder. 30 degrees. I know you were all concerned that I didn't write a 60 degrees at the top. But I just didn't want to have to erase it and write 30 and 30. Right? But if I bisect that 60-degree angle, I split it into 30 and 30. So now, what do I have in each side of this triangle? I have a 30, 60, 90 triangle. What else do we know about this? About these two triangles? They're right triangles. What else do you know about them? Are they congruent? Well, the hypotenuses are the same. The base pieces are the same. What about the height? Is it the same in each one? It's a perpendicular bisector. So we have a special, it's the second special right triangle. Okay? So we had one special right triangle we talked about. Do you remember what it was? 45, 45, 90. That was the special right triangle. And 30, 60, 90 will be our second special right triangle. There are only two. They're very special. If I know the distance, the side length of an equilateral triangle, let's just make it be 6. If the side of my equilateral triangle is 6, what's this other side of this equilateral triangle? 6. What about the bottom?
6.
6. Okay? What happens now if I want to divide this triangle and just look at one piece? One of my two congruent right triangles. What's this length?
3.
3. How do you know it's 3? Because it bisects. It cuts it in half. Now, how in the world can I find this height? Can I use the Pythagorean theorem?
C.
So let's plug it in. So 3 squared plus 8 squared equals 6 squared. So I'm using just the purple triangle because it's the only one that's a right triangle to solve for the height. Or if you want to put a B there, it's okay, or an A, it doesn't matter. So h squared equals, what's 6 squared? Minus 3 squared, 36 minus 9.
Oh, this was much trouble last time.
We're subtracting 9. Don't subtract 11. So h squared will equal 27. It's okay, you're definitely not the only one who's done that, even today.
11.
But they put 25.
Oh.
Because it's nice, so it would come out nice. But they're not going to come out nice. The 45, 45, 90 didn't come out nice. So how do we solve for h?
You do the thingy.
What thingy thingy?
That
You have to.
The tree. So we're going to have to do the prime factorization or simplified radical form. So square root of 27.
3 and 9.
So would I use 9 and 3? Am I going to use just the number 9 and just the number 3?
No.
Square root. So it's the square root of 9 times the
3.
square root of 3. We get the square root of 27. Square root of 9 is 3. Square root of 3, you're done. So h equals 3 on the square root of 3. Oh, right, too close to the bottom. So h equals 3 on the square root of 3. Same in both triangles. Right? Simple enough. Let's look at another. And I'm just going to draw the half, the 30, 60, 90 degree triangle. Okay? Now, if I give you the hypotenuse is, let's just do 8. Can you find the two other side lengths? Now, I'm going to start calling these, because it's a right triangle, we have legs. We have a short leg and a long leg. Why is this side right here the short leg?
Because it's shorter.
It's shorter. So what? What about it? The opposite, the shortest or the smallest angle. So smallest angle, the 30 degrees, will always be opposite the short leg. Okay? Now, what about this? It's opposite 60. What leg will it be? It will be the long leg. It's not the longest side. This is the longer leg. There's a short leg and a long leg, and the 8 will be the hypotenuse. Okay, so being able to see that, we've got a short leg and a long leg and a hypotenuse. So if I wanted to solve for the short leg, what is the short leg? If you know the hypotenuse, sometimes I will do this. I'll pretend to draw the equilateral triangle. Okay, if this is 8, what's this total length? 8. And what did I do? I cut it in half. So the short leg will always be half of whatever the hypotenuse is. Okay? And then can we solve for the long leg? Yeah. I'm going to put a y out there. There'll be a lot of x's and y's. So can we do 4 squared plus y squared equals 8 squared? So I'm going to do this. I'm going to go a little bit quicker. 8 squared is 64. 4 squared is 16. When we subtract that, what does y squared equal? It's 48. How do we find y? We take the square root. Exact values are always good. Simplify the radical. So how do we break down the square root of 48? 6 and 8. Do I know the square root of 6 or 8? I probably would not use 6 and 8. You could. Do you want me to do it that way? It
Yes.
takes longer.
Yeah, but
Way easier because
It is. But most of you won't do it that way. I personally will never do this. Okay? But I know you will, so let me show you what to do. Do you know the square root of 6? Do you know the square root of 8? No. So you have to keep going. Square root of 6 is? Square root of 2 times the square root of 3. Do you know the square root of either one of those? No. Square root of 8. Square root of 2 times the square root of 4. Wait, do you know the square root of 4? Yay! But most of you won't even do that. You will leave it square root of 2 times square root of 2. Okay? So, what do we do with the square root of 2 times the square root of 3 times the square root of 2 times the square root of 2 times the square root of 2? Don't pull your calculator out. Okay. What do? What's the square root of 2 times the square root of 2?
2.
What's the square root of 2 times the square root of 2? Does everybody agree? I can put these two together and that'd be 2. And then we have a square root of 3 out there somewhere. So that just gets brought down, square root of 3. So what's the square root of 3 times 2 times 2? So what does y equal? 4 root 3. So my long side is 4 root 3. Okay, I'm going to do another one. Okay, this is the only time I will ever do this. Ever. Don't do it. Huh?
We get it now. It says it on the thingy. The root 3 is the thing.
If I give you 30 degrees and 60 degrees, and I give you 3, can you find the other two sides?
See.
Wait. Pause. What side did I give you? Did I give you the hypotenuse like I have given you?
No.
I did give you the hypotenuse?
Yes, because if it is a 30, 60, 90, and you show the other side of the triangle, then your base is 6. And since it's equal, it will form an equilateral triangle, which means it will have the same
Why are you
side.
talking?
So y has to equal 6.
But I did not give you that. That's the easiest thing to find.
Jackson has such a big brain that if you give him anything close to it, you give him.
Could I say the hypotenuse is equal to 2 times the short leg?
One could.
Okay? So if you have the short leg, you simply multiply it times 2 to get the hypotenuse. Yes? So y equals what?
6.
6. Okay? How are we going to get the long leg?
Right? It says on here.
If you do the Pythagorean theorem, what happens? X squared plus 3 squared equals 6 squared. So x squared equals, did we just do this one?
Oh my god.
Oh my gosh. Do we need to do a different one?
No.
You get 3 root.
Yes.
36 minus 9. 36 minus 9 is 27. Oh, you're going to have to do another one.
It says it in the name.
Okay, the fun thing is reading something in a book does not mean that you're going to remember it. I mean, my experience. Maybe you remember everything you read in a book. Yes? Sometimes people do that. So when you break it down, what is x equal to? 3 root 3. What is common to every triangle that you've done today?
It's rooted in
It's a root 3.
Oh no.
So, is there,
Oh my
an
god.
avid root.
so
Oh my god.
is the long leg equals to the short leg times what? Nope, root 3. Now, I won't generally say the word leg in these. I'll just say short and long, just so you know what I will do. So, the long leg is the short times root 3. Those two things are very important to know. So that if I give you something different, can you draw and find the other missing side lengths? Do I have to do the Pythagorean theorem every time?
No.
No, we don't. All right, so let's talk about both of our special right triangles. What type of triangle is this? It's a 45, 45, 90. If this side length is 1, what are the other two side lengths? 1 root 2, or just root 2. Okay? Every 45, 45, 90 triangle has how many congruent side lengths? 2. There's a 1 and a 1. We have a root 2. There's two sides of the same. Root 2 goes with it. Okay? This is just how it helps me remember things. Then we have a 30, 60, 90 triangle. These are our two special right triangles. There's 2, only 2. Opposite 30 degrees. Could I put a 1 there if that's my short side? If that short side is 1, what's my hypotenuse? 2. If my short side is 1, what's my long side? 1 root 3, or just simply root 3. Okay? These two triangles I draw, I feel like hundreds of times every school year. I've told you this before. These are important triangles. I forget who I told it to. Okay, I told you. Don't say it anymore, Miss Evans. Okay? Very important triangles. Okay? We're going to use these triangles for a long time. Now, you'll see them back and forth. You won't get them to your daily, everyday life until you're more a junior. And then we're going to come back to these triangles and trig. And we're going to use them all the time. Okay? So, what happens if I give you, I feel like I need to write those equations up there again. Can I write them? The hypotenuse equals what? 2 times the short leg. What about the long leg? Short leg times root 3. Important. I think this is the second time I've written this. Oh, I know what else I wrote. 30 degrees will always, I don't use the word always very often, will always be opposite the short leg. 30 degrees will always be opposite the short leg, no matter where it is. I have this really bad habit of drawing 30 degrees at the top every time. It won't always be drawn there. Okay? It will not always be drawn there. But you always know opposite it has to be the short leg. Okay? So are you ready if I start mixing it up?
Of course.
Of course. All right. We'll start out nice. I'll do this, and then I'm going to ask you another question. So find x and y, and then find the exact value of the perimeter. So you have to find x and y, And then what do you do to find the perimeter?
Of the whole equilateral triangle? Or
No.
the right triangle?
The right triangle that's drawn there.
Oh,
Only the triangle that's drawn there. I'm sorry. Okay, I want exact. Generally, that doesn't mean plug it in your calculator.
Dang. Did something wrong.
Decimals are not exact.
This is true.
I want exact. What does that mean?
Yes.
So what did I give you? Did I give you the short side, the long side, or the hypotenuse?
Almost the perimeter.
Yes.
The short.
I gave you the short side. What's the easiest? Which, who knows which one is easier? They're both fairly easy. Which one did you find first, Riley? You found y. What is the value of y? 10. Lucas, what did you get for x?
5√3.
5√3. That is an exact value. How do you find the perimeter? What do you do to find the perimeter?
You have to add everything
Add everything together.
together.
How do we add 5 plus 10 plus 5√3?
Almost done.
You can collect like terms. What is like in this scenario? That root 3. Does anything else have a root 3?
No, so you nothing. Make it like it.
5 plus 10, is that a number plus another number? Is there any variables or any square roots with it?
No.
So what's 5 plus 10? 5 plus 15 plus 5√3. You can only add square roots if the other pieces have the same square root. Like if you have 2√3 plus 5√3, that would become
7√3.
7√3.
Amazing.
Okay?
It's like magic.
Yes.
Okay, I got 5 root 5 and I can't figure out where that's
This is your hypotenuse. This is your hypotenuse. Yep. That's what happened. That's okay. Alright, so we can't be done. Okay, I was like, I thought people were getting up. 35 is the other day. We have 45 today. Good. Okay, what happens if? Oh, I don't want that. What is going on? Do you need to share with everybody?
Nah, it's good. I'm ready to focus.
Okay. I think Lucas just said, I think I want the harder problem. I don't want you to go easy on us.
We want the hard.
You want to go, you're going to ride on the interstate. What happens if I give you this number is 6?
This is too much for the brain cells.
Too much.
Hold on. Wait, hold on, Jackson. Let's do this. Oh my gosh, I got it.
Should you need a calculator?
You should
See.
I want exact values. So you're not plugging anything into a calculator. And I gave you a small enough number that you know what 6 squared is. Where are your equations? What did I give you this time? Did I give you the short side? Did I give you the hypotenuse? What did I give you?
You gave us the height.
The what?
The height. If it was I don't know what it's called there. That was the long side.
The long leg. Did you have an answer? Give it to me. What is it?
I got 18 over root 3 plus 6.
What did I ask you to find?
Oh.
I didn't ask you to find the perimeter,
Oh.
but
Oh, then those are the parameters.
so what is root 3? If you have the short side, you multiply times root 3 to get the long side, right? we all have this equation. Long equals the short times root 3. Which piece up here do you have?
The long.
You have the long. So plug that in. Right? So what the long, which is 6, equals the short, which is x, times root 3. How do you solve for x? Divide by the square root of 3. Over here, those cancel. What does x equal?
6 root 3, but you don't want to.
Can you leave an irrational number in the denominator? No, what do we do with it? What's that word? You have to rationalize the denominator. Meaning, I don't want this irrational number there. I want it to be rational. Do you remember what we did? Whatever irrational number is in the denominator, you multiply by that number over itself. Loudest writing ever.
No, it's the pen. It's weighted, so it's.
Say weighted.
Wait,
Yes.
so if you like put it in the wall, will it like stay there?
Let's don't try that. At your own house, you can try that. Don't try that in my room. So what do we do when we multiply these two fractions together? 6 times root 3. 6 root 3.
Which is emphasis
What's root 3 times root 3?
3. Silly goose. 6 root 3 over 3. Oh my gosh, bro. Over 3.
Oh, okay, so it makes root 9 is That's better.
So you know the square root of 9
It's upside down, too.
is 3. Wait, are we done?
No,
we're
never
done.
done. God, your math's going
Can
on
we
forever.
please
It can't be done.
reduce that 6 divided by 3?
What we can. Oh yeah, we
It's
can.
2 root 3.
Is x simply 2 root 3? Woo!
Yeah.
That is crazy.
And then you do
That
times 2.
is
Now,
absolutely.
If you have the short side, what do you do to get the hypotenuse?
You multiply by 2.
So how the hypotenuse is 2 times the short side. How do you multiply numbers and irrational things? If you have constant numbers, you multiply them together. If you have irrational numbers, you can multiply them together. We only have the constants, the coefficients. So can we multiply that together to be what? 4 root 3. So y equals 4 root 3. Okay? Well, we could do another one of those.
I think we're good.
You think we're good?
Yes.
I'll come back to it then, just for you. What happens if, here's the next one, equilateral triangle. Okay? Equilateral triangle with a side length of 10. Because we've already found the perimeter of something. Can you find the exact value or the exact area of this triangle?
Oh my gosh.
Go for it. What are you going to do?
Oh yeah.
Let Jackson figure it out too.
See.
Is that your answer?
No.
Okay.
Never judge a book by its
You'd be wrong.
Is this one right?
Why you gotta be like that, bro?
Please stop.
I
Nice.
I did based on time.
You forgot to find the height. Oh. Do you have to find the height? Yes. And then simplify? Yes. But now, because used to, in this type of triangle, there'd be a little dashed line right down, right?
Yes.
And at the bottom of that dashed line, what would it have?
little right thing.
And usually they would give you the length of that dashed line to be the height. But can you find the height? What is it? 5 root 3. Because you know that this is 5, correct? Because it's half of a 30, 60, 90 triangle. It's half of an equilateral. Okay? Which makes it 30, 60, 90. You know the short side is 5. The height has to be 5 root 3. So what is the area of a triangle formula?
1/2 base times 1.
We still have to do 1/2 though.
So what is the base?
5.
Ooh.
10
Oh,
times 10.
10.
1/2 of the base, because I want the area of the whole thing, times the height.
Oh my gosh.
So yeah, half of 10 equals 5. 5 times root 3 is 25 root 3.
So it's okay just to use 1/2.
You're going to do half of it again. Just don't do half and half again. Okay? All right? Can we do one more? Jenny, did I do that too quick?
Sure.
What are we finding today?
We're just already at the bottom.
Ah, yeah.
That's
Piece of cake. Not even.
Putting that up there a few times. Hope you have it at least once. And what in this do I have? Long equals the short times root 3. Which piece do we have? So when you divide by the square root of 3, x equals 8 divided by the square root of 3. What are you multiplying by? Rationalizing. Did you get 8 root 3 over 3?
Yes.
Can you simplify that? Do I want a repeating decimal? Do not. That is x. How do you multiply it times 2 to get to y?
16 root 3
Divided by what?
3. Let's go.
Okay. Those are our 2. Now, we do have some homework. I don't know what page it's on. We're going to do lesson 56. Do what?
Have we had
No, we haven't.
So is this
This is our first practice lesson, and then 1 through 3, and one, I forgot what's the other one I added. Thought we were gonna go-
What was the answer to the last one?
It was 8 root 3 over 3, was x, and the other one was 16. Yeah, so we multiply times 2 over 1. And it becomes 16 over 3. Also, I think I told the other class, I don't remember if I told them. Okay. I had originally scheduled a homework quiz for next Tuesday. So we're just not going to be able to fit in. So I might just take up a homework as a homework grade at some point in time.
Like a random one?
That would be.
Or- Yeah. Or maybe a random 1 or 2 together.
Oh, dose.
actually that's my next grade.
Probably so, the more problems there are. Alright, have a great afternoon. Forgot I need to stop recording.